That's so mean.
I'm sorry.
Josh, you're bullying.
Do you feel bullied?
So, do you guys have any questions about any of these four?
No. See? There you go.
Small questions, big questions, anything at all. Walking around, I saw a lot of folks had number 1 and number 2 correct. Certainly encouraged by that. Number 3 is a little more of a mixed bag. Number 4, there was a fair number of correct answers. That was encouraging as well. Anything at all? Question-wise?
I will make it. I will make it.
You have to practice a lot because right now,
I have a question on the graphic.
Sure. Hey guys, would you listen up, please? Colton, go ahead, buddy.
I don't know how to graph X is greater than 1.
Sure. So let me just get rid of all this. And we can build as much of this up as we need. So when you only look at this one right here, x is greater than 1, it does look different than the other two because the other two both have a y and an x, right? So my way of reminding myself about this is always going to be that little ski analogy. So if there's only an x and you tried to ski it, you'd get x'd out because we're talking about a vertical line. So I would put a vertical line at 1. So that would look something like, not that. How about this? Wow, why is it doing that? That's a little better. So vertical line at 1. Does that part make sense as far as the connection between? Okay. And then when I look a little closer, I can see that it is, it's just x is greater than. There's not the or equal to with it. So that means this needs to be a dotted line. So I'm going to go back through here and erase little chunks of it so it's dotted now. And then as far as the greater than or the greater than and the shading, aren't I going to shade, at least for this one, aren't I going to shade either over here in region A or over here in region B? Yep. So I would do a test value. So if I'm a fan of 0, 0. So if I tested out 0, 0, that means x is 0. Just plug that in. So is using this, I would say then that 0 is greater than 1. Is that true? It's not true. That means that 0, 0 is not my answer region. It's got to be the other one. So I would shade on the region that's not 0, 0. So I'd be shading over there. That's just for the vertical line. Are you okay with the other ones? Yep. Okay. Thank you for asking. Anybody else with a question or concern? So I can give you some time and space. So tomorrow we're going to do our DMR quiz. I'm sure most of you know I put the DMR on yesterday's video. So if you want to go back and rewatch that a little bit, this one is being made as a video too. You can go back and rewatch, consider any of those. So last chance. 5x plus 2, negative 45, that graph you saw earlier, and then negative 1 root 7. Or a couple folks asked about this. This would be just as good if you had just negative root 7. That's fine too. Same thing. Okay, so you all have had plenty of chances to look things over. So let's go ahead and move forward. Grab your notes packet for success. Please consider these with me. I want to review how we add like terms, and I want to hear you guys do this. Certainly you've done enough of this. Take a look at number 1. If I was going to take that expression right there and try to simplify it, 4x to the 4th plus 81x to the 4th, what do you guys think the answer would be if I combine this down, I simplify it? 85? 85x to the 4th is right. When you add your like terms, if they are like terms, you add the coefficients, but you leave the variable alone, right? Still x to the 4th. What do you guys think of number 2? 17x squared y squared plus 2x squared y minus 6x squared y squared. Do you see any like terms?
Yeah, I do.
Which ones are like terms?
17x squared y squared minus x 6x squared y squared.
Whoa.
That one and then the end one.
So in other words, the first one and the third one, right?
The first.
Yeah.
Would you guys agree that the ones that I put in boxes are like terms?
Yes.
Can anyone explain why the middle one is not like those. Noel, what do you think?
2x is the y is not squared. The other ones, the y is squared.
Yeah, that's exactly right. So it's very close, but it's not quite. So what do you guys think would happen if I did add those two like terms in the green boxes?
You actually subtract
11, yep. 11x squared, y squared.
plus 2x squared y.
And so that would just remain in your answer line, right? It's not like the other terms.
It would.
Does it make sense?
It does.
Shh. Hey, is this, you don't need, this is a rhetorical question. You don't need to answer this. But consider for a minute, numbers 1 and 2, do they feel like review? I hope they do. I hope they do. So if they do, then I am hoping that a question like number 3 will be pretty comfortable for you. I'm going to give you just a little direction on this. I'm going to have you guys try to finish this. I've got some polynomials, and let's review this real quick. The first polynomial, if we were going to name, I'll highlight it for you just so we all know what we're talking about. The first polynomial right here, what name would you give that one? It is a trinomial. What's the degree?
The degree is squared. Technically
2, second degree. Degree is 2. Yep. What's the lead coefficient for that highlighted polynomial? 3. 3 is the lead coefficient. That's right. How about the other one? What would you name the other one? Trinomial. Degree 2. And the 4 is the lead coefficient. Very well done. So guys, here's how you handle this. You're going to want to pay attention, because if this symbol here is a plus or a minus or a times, whichever one it is, it makes a massive difference as to what we're actually doing. So for instance, I'm gonna round up and be generous to myself. I'm really 5'9", but just for sake of numbers, if I told you that I was 6 feet tall and we finished out the semester and we go through the summer, listen. And I told you next fall, guys, my height increased by 4 inches. I added 4 inches to my height. Would that mean that I was 6'4" or 24 feet tall? Doesn't it make a huge difference whether you add or multiply? So we want to pay really close to 24 feet tall. That would set a record, wouldn't it? I could dunk it with my knee, right? Like, I want that guy on my basketball team, right? Okay, so listen. This symbol here in the middle is a plus sign. So that tells us we are doing something very specific, and I want to help you start off with this, and I'll let you finish. Here we go. If you are adding, Josh, listen please. If you are adding polynomials, not multiplying, not subtracting, if you are adding like this one, here's what you do. Step 1 is you drop all parentheses. You simply drop them. You don't need them. This is if you are adding. If you're doing something else, this doesn't work. This is the nature of addition. Once you've done this, you simply add like terms. So why don't you try that? Ready, set, go. If you haven't already done that, please take your like terms, let's combine them, see what you get. Give everybody a chance. I'll get your answer here in a second.
What if I want to do it with both? Don't judge me. You know what? There's a verse in the Bible about judging. Have you read it yet?
No, I haven't. Have you?
Okay, Nick, you got this? Josh, be quiet, please. Shh. Should be able to hear Nick. He said it pretty clearly. Did y'all get this? 7c squared minus 9c minus 2. It's a good job. It's very well done. The other one I wanted to show you here today before we move on is how we subtract polynomials. And tomorrow we'll probably review this a little bit. But I thought we'd finish off with this one here. So this is really important for us to notice that this is not the same symbol as what we just did, right? We are not asked to add the polynomials. We are asked to subtract them. So this will require us to do a slightly different approach to this one. And here's what you do.
Sorry.
Yeah. The first one, the first polynomial, all you really have to do is drop the parentheses. So that's what we do. 3y squared minus 4y minus 6. Now the second one is different because we're not adding, we're subtracting. The question is, what is it that I'm subtracting? Am I subtracting 2y squared minus y plus 9 or all of it? I'm subtracting, well the parentheses tell me it's all of it. And so the way I handle it is I actually distribute the minus sign to all of it. I'm not subtracting the first, second, or third term. I'm subtracting all of them. So this would be minus 2y squared plus y minus 9. Once you've gotten to that place, like we did before, you would combine and add your like terms. So take a minute and do that, and that'll be that for the day. Irene, do you have these added up?
How I yawn.
What'd you get? Hey guys, I need to be able to hear Irene, so please be quiet. Go, Irene.
Got him.
I agree. Well done. Okay.
Do you need help?
Very good. Oh wait, let's get your desk cleared off. You can have a calculator. Get your desk all facing this way. We'll get ready for your quiz.